Okay, so in terms of solving trig equations, I guess there's some steps that we take through, all right? Um, I guess the first thing to consider really is if I want to do, if I wanted to solve, for example, where sine is equal to a half, well, there's the y value of a half there. Have a look how many solutions there are. In fact, there's an infinite number of solutions because sine and cosine and tan graphs go on indefinitely. So the first thing to realize is, depending upon the domain will tell you how many solutions there are you need to find. Okay? So in terms of finding those solutions, first step is find the angle that you need to deal with, and then find which quadrants will find the angle in the appropriate quadrant to give us our first two solutions. Those two solutions will be between 0 and 2 pi. And then we're going to use our symmetry properties to find the rest of the solutions. And those rest of solutions, now there's two ways we can approach it. In here we talk about adding or subtracting the period to the two solutions. I'm going to do it by adding or subtracting 2 pi to the solutions. So it's just a little twist on the same process, and you'll see what I mean in a minute. So let's have a look at an example. Find the solutions to sine x equal to 1 on root 2, where x is an element of 0 to 2 pi. So first things first, if we were to sketch this graph, the period is 2 pi. The maximum value is 1, so there's pi. We finish at 2 pi. So there's our graph here like this. Okay? And whereabouts does sine x equal 1 on root 2? So 1 on root 2 is about 0.7. So if I put the line at about 0.7, we can see there's going to be two solutions roughly here. All right? So to work out our solutions, our processes, if I want to solve sine x equal to 1 on root 2, that means x is equal to sine inverse of 1 on root 2, which is equal to pi on 4. Sine of what angle gives me 1 on root 2? It's pi on 4. Then what I do is I come in and say, okay, I need sine to be positive 1 on root 2. Whereabouts is sine positive? Well, sine is positive there. So let's put pi on 4. Sine is also positive in this quadrant. So that's pi on 4. Then what I do, starting at 0, I find my first two solutions. So my solutions are given by, well, there's my angle x. So x is equal to pi on 4. If I go all the way around here to pi, and then double back a fraction, it's pi minus pi on 4. So the solutions are given by pi on 4 and 3 pi on 4. If by chance I extended this graph to there and came down again, you can see straight away I've got two more solutions. And from our symmetry, my solutions, the distance from that x-intercept to that, sorry, not x-intercept, but that's point of intersection, and the distance from that point of intersection to that point of intersection, it is the period, which in this case is 2 pi. All right, so actually let's do it that way. So in this case, it's 2 pi, which means my next solutions are plus 2 pi and plus 2 pi. So 8 on 4 plus 2 pi, which is, sorry, pi on 4 plus 8 on 4 is 9 pi on 4. 3 on 4 plus 8 on 4 is 11 pi on 4. So they're my next two solutions, okay? If by chance I had to get some negative solutions, go something like that. I've got that point there. Well, I subtract 2 pi. So I could get, we'll come backwards a bit from here. Let's go backwards and minus 2 pi, backwards, minus 2 pi. So I'd get 3 on 4 minus 8 on 4, negative 5 pi on 4. 1 on 4 minus 8 on 4, negative 7 pi on 4. So those there and there are my extra solutions if I had to find them. So it's finding the first two just by going around my unit circle and then adding the period of the function or subtracting the period of the function from those solutions to find the rest of them. All right, so let's have another go. So first step for me is always going to be to draw the little crosshairs. And we ignore, so the negative sign tells me whereabouts is sine theta negative. So sine theta is negative there and there. Okay, because sine is my y value and my y value is a negative there. So I've addressed the negative sign. So now if theta is equal to sine inverse of root 3 on 2. So sine of what angle is root 3 on 2? And that angle is, check your exact values, pi on 3. So sine of 60 degrees is equal to pi on 3, is equal to root 3 on 2. So that means that's root pi on 3, and that is pi on 3. So let's just get the first two solutions the same way first. So start at 0, go around to pi, no solutions there, but now I add pi on 3, so my solutions are given by pi plus pi on 3, and then go all the way around here to 2 pi, and come back 2 pi minus pi on 3. So theta is equal to 4 pi on 3, and what's 2 is 6 minus 5 pi on, 5 pi on 3. So they're the first two positive solutions. Have a look at our domain. It's got to be between negative pi and pi. So I need negative solutions. So what I need to do now is the period of my graph is, the period of my graph is 2 pi on 1, which is equal to 2 pi. So I subtract 2 pi from that answer and subtract 2 pi from that answer. So that means my theta is equal to 4 on 3 minus 6 on 3, which is negative 2 pi on 3. 5 on 3 minus 6 on 3, which is minus pi on 3. So those two answers are within that domain. So they're my solutions. Okay. Now it's quite possible I could have got them starting from 0 and going backwards. 0 minus pi on 3 is negative pi on 3, and all the way around back to here makes that negative 2 pi on 3. Okay, but I don't mind you getting into the habit of starting with 0, going around the circle once in a positive direction, get your first two solutions, and then add and subtract the period to get the solutions that fit inside the domain. All right. Lucky last. Okay, so what happens here when we've got our little 2 theta there? So let's just get things a little bit bigger for us. So processes are the same. I'm going to do my little crosshairs. Sine theta is negative here and here, and I want to get sine inverse of root 3 on 2. So what angle gives me root 3 on 2? for sine, and again, that's 60 degrees, which is pi on 3. So that angle there is pi on 3. That angle there is pi on 3. All right. So I'm going to do exactly the same thing. I'm going to start at 0, go around to pi. I get pi plus pi on 3. Now the difference is here, instead of it just being a single x or a single theta, I've got 2 theta. So that means 2 theta is equal to my answers. So that's pi plus pi on 3, which is 4 pi on 3. And I get around here to 2 pi minus, that's 5 pi on 3. Okay? Now if I divide by 2, I get theta is equal to 4 pi on 6, 5 pi on 6. All right? So notice both of them now fit inside that domain. All right? To get the rest of my solutions, I've got to add and subtract the period. What's the period of this graph? Well, the period is equal to 2 pi on 2, which is equal to pi. So, which if you like, is 6 pi on 6. So I'm going to add and subtract 6 pi on 6. So my next two positive ones, 4 plus 6 is 10 pi on 6. Well, I'm going to stop there because that's bigger than pi already. Let's subtract now to get 2 more. What if I just, we'll go this way still, but let's subtract. 4 pi minus 6 pi on 6 is negative 2 pi on 6. 5 pi subtract 6 pi is negative pi on 6. If I subtract any more, negative 1 minus 6 is negative 7 on 6, which is too big. Negative 2 minus 6 is negative 8 on 6, which is also too big. So what does that mean? That one there is outside the domain, but that one, that one, that one, and that one is inside. So they're my 4 solutions. So it is possible, just come down a little bit. 4 pi on 6 is the same as 2 pi on 3. 5 pi on 6 I can leave. Negative 2 pi on 6 is the same as negative pi on 3. And negative pi on 6. So there's my 4 solutions there. All right. So the key to remember, the angle is equal to whatever it is, add and subtract the period. Okay.